we received new images of an object with three eyes, a third interstellar body observed from Earth, which is now rapidly moving through our solar system. Former Harvard astrophysicist Avi Loeb suggested that this object might be some kind of alien technology. The title, Three-Eyed Atlas, has sparked great interest in astronomical circles since its discovery, but what recently happened shocked both seasoned scientists and space enthusiasts. Without any prior warning, the interstellar object abruptly changed its trajectory. As if an unseen hand pushed him off the expected path, the calculations that once predicted his smooth, predictable route suddenly became invalid. Tracking stations, observatories, and research groups around the world rushed to understand what had just happened. This event was not only rare, but also alarming, as in the world of orbital mechanics, objects do not change direction without the influence of a powerful force. The panic was not theatrical or exaggerated. It arose from the realization of the critical information such a change carried. Every celestial object is governed by the laws of motion that control the universe, and deviations usually have identifiable causes, such as gravitational influences from planets, emissions from comets, or collisions with invisible fragments of rock. However, the three-eyed atlas was not near large bodies that could explain such a sharp change, and its activity did not indicate a large-scale emission that could direct it in a new vector. What the scientists observed seemed unnatural, though many hesitated to say the word aloud. This left them in anticipation, staring at screens, reviewing data, and whispering possible explanations, which only deepened their anxiety. They tirelessly tracked his movement, noting that the altered path had not just shifted slightly, but deviated enough to change its long-term direction. The speed of the object also seemed altered, although initial data required careful verification. The team studying the interstellar traveler since his arrival in the solar system were now reviewing their previous models, realizing that the accuracy of their predictions was at risk. Questions multiplied in the academic corridors and during late meetings. Is this a case of unknown physics or an anomaly so significant that it could rewrite our understanding of cosmic dynamics? The nature of the object has always been strange. Unlike the interstellar traveler Lian Oumuamua, which became the subject of heated debates about its shape and possible artificiality, the three-eyed atlas seemed less dramatic. It was classified as a comet-like body exhibiting barely noticeable activity, giving it a more familiar profile. The scientists were more confident in their assessments. This confidence vanished the moment his orbit unexpectedly changed. The words "sudden change" brought with them a fear of unpredictability in a world where predictability should reign. For several hours, the global network of astronomers filled with messages. Data was transmitted in real time, but the more information came in, the stranger it seemed. Astrodynamicists, who dedicated their lives to trajectory calculations, acknowledged that they had never encountered such a discrepancy without an obvious reason. There was an urgent need for action. If a comet or interstellar object can suddenly deviate, how many other objects might do the same without warning? How could this affect planetary defense systems that rely on accurate predictions to intercept dangerous bodies? The consequences extended far beyond this one object. If the Tri-Epsilon Atlas reacted to something, what could it be? Was there a region of space exerting an influence we had yet to recognize? Could there be concentrations of dark matter acting in ways we haven't accounted for? Or some exotic physics hidden in the depths of interstellar space? Each hypothesis carried serious implications. A simple change in the path meant the need to reconsider assumptions about forces, stability, and the subtle structures of the cosmos that remain invisible to our instruments. The teams tried to determine the exact moment of deviation. They studied archival images, radar echoes, and spectrographic signatures to determine when the laws of motion betrayed expectations. In this data, nothing stood out. There were no harbingers indicating instability. One night, the object was where it was supposed to be. The next one, no longer. This dual revolution shocked the community. Even comets experiencing dramatic gas emissions usually show progressive signs. 3 Epsilon Atlas simply broke all the rules. Accustomed to precision, astronomers felt their sense of security crumble. Telescopes focused almost exclusively on this object. Other observations were postponed, as Tri-Epsilon Atlas occupied the schedules of major observatories. Simulations ran on supercomputers all night, not only to predict his new route, but also to test all known physical mechanisms that could explain this leap. But the results led to dead ends. For every potential explanation, the numbers refused to add up neatly. The growing conclusion, spoken with hesitation, was that something completely unexpected had intervened in the process. Panic was not about the imminent collision. It was related to an intellectual crisis. If space can exhibit such behavior, then the foundation of celestial forecasting is flawed. Navigation systems for spacecraft depend on these forecasts. The entire infrastructure of space research, from launching satellites to planning interplanetary travel, relies on trust in orbital dynamics, and this unpredictable anomaly threatened that trust. Engineers and space agencies could not ignore the possibility that their equations were missing a critically important factor. While public statements sounded cautious, behind closed doors the situation grew more tense. Data sharing agreements, which usually moved slowly, were accelerated. What rarely collaborated in astronomy suddenly began exchanging data in real time. Everyone understood that this was not just an academic puzzle, but a phenomenon requiring a collective human response. Each scientist observing the unconventional new path of the I/Atlas felt the weight of this realization. Astronomers were trying to determine whether small jets of gas erupting from beneath the surface could be the cause of what was happening. Ultimately, such eruptions are known for their unpredictability, as the heat of volatile ice and pressure can cause sudden bursts. However, the calculations again did not confirm the hypothesis. The energy required to cause the observed change exceeded the recorded data. The jets would have to be orders of magnitude stronger than anything ever recorded, and there was no evidence of such power. This possibility was not completely dismissed, but was placed low on the list of probabilities. Another considered possibility was gravitational interactions. The object could have slipped past an invisible body, possibly a smaller asteroid or a dark fragment too weak to be detected, but orbital calculations revealed no candidates. Space is vast, but the models accounted for known fields of space debris and neighboring trajectories. The change appeared isolated, without a nearby culprit to blame. Some researchers began discussing more exotic versions. Could interactions with interstellar magnetic fields cause subtle jolts that accumulate? Could there be something in quantum mechanics that manifests on a macroscopic level, only visible to these rare interstellar travelers? Such assumptions were usually left on the sidelines of scientific discussion, but in the tense atmosphere surrounding the 3I/Atlas, even the unlikely was openly debated. The absence of a traditional explanation created fertile ground for speculation, each becoming increasingly dramatic. Soon the public learned about the situation, and although scientists avoided harsh statements, the idea of a possible change of course spread like wildfire. People understood enough to realize that if objects could suddenly change their position, predictions about safety became less reliable. The term panic emerged not because cities feared an imminent strike, but because the guardians of cosmic knowledge were unprepared. The keepers of orbital forecasts were frantically searching for a solution, and this image alone became quite alarming. Human imagination thrives in uncertainty, and this event actively fueled it. Discussions about the mysteries of space surpassing our understanding became much more intense. Every astrophysicist, immersed in writing equations at night, had thousands of ordinary people gazing at the stars and wondering if something much stranger than science predicts was quietly happening above them. The boundary between strict calculations and speculative excitement blurred. In the observatories, a sense of fatigue grew as data streams continued to flow. Every change in brightness, every fluctuation in trajectory, every hint of acceleration was recorded and carefully analyzed, with teams working on models that went beyond Newtonian mechanics, delving into relativistic corrections and even more abstract theories. This object became not just an interstellar guest, but a test of the resilience of human understanding. Can our perception of physical laws withstand what seems to mock them? The atmosphere among scientists was divided between delight and fear. On one hand, the chance to observe a true anomaly was a dream for researchers. On the other hand, the collapse of predictive certainty was a real nightmare. If forecasts fail here, where else might they go wrong? Mapping routes for decades ahead, missions suddenly had to account for unexpected deviations that might lie in their path. Space agencies tirelessly worked to protect Earth from dangerous asteroids, realizing that the threat could take on a new dimension if trajectories were not as fixed as assumed. The interstellar object, now gliding along its mysterious new path, became the center of a deep confrontation with the unknown. Scientists moved forward with determination, but the feeling that the universe had just pulled the ground from beneath them remained. The change in the course of the 3I/Atlases concerned not only one ice traveler, it affected the reliability of the space frame itself. The telescope, aimed at him, bore the weight of expectation, fear, and relentless human striving to decipher what seems beyond understanding. As days passed and reality's data confirmed, the tension did not ease. It only intensified, as with each measurement it became increasingly difficult to avoid the conclusion that something profound had just been revealed in the movement of a solitary guest from the stars. The alteration of the trajectory of three eye/atlases not only caused confusion among the scientists, it awakened a deeper confrontation with what humanity thinks it knows about the universe. Every hour after the first discovery of the anomaly brought new calculations, new simulations, and new anxieties. The numbers confirmed that this was not a minor fluctuation, not an error in measurements, but a real and measurable change in the course of the space traveler. His confidence in movement, once marked with certainty across vast expanses, was shattered. And in the silence of this realization, entire disciplines faced the unknown. For astronomers, the problem was clear. The cosmos should have been predictable. Mass, speed, and gravitational environment determined the path of any body. However, before them was an object that seemed to ignore all known laws of these forces, prompting the teams to delve into aspects of orbital mechanics that were rarely questioned. The task involved not only recalculating the new trajectory, but also explaining how such a path could exist without contradicting centuries of observations of celestial bodies. The era of telescopes provided us with precise data on planetary orbits, measured to the second. The accuracy of spacecraft trajectories was at the level of millimeters per second, and the catalog of comet dynamics seemed almost complete. Now, with the emergence of the Object 3 eye/atlas, all this precision was undermined by something that refused to conform to known laws. Astrophysicists turned to the chemical and structural composition of the object. Is it possible that inside it lay vast cavities filled with compressed gas that suddenly released their charge, giving it momentum? Spectrographic analysis showed that the object's surface is rich in volatile substances, but none of the measurements indicated the presence of explosive energy reserves ready to surge. The observed change was too abrupt and significant to be explained by gradual heating or sublimation. Scientists faced a troubling possibility that this object was unique in ways they had never suspected, and that its internal mechanisms operated on principles unlike anything in the solar system. The very name 3 eye/atlas as an interstellar object underscored the intrigue. He came from beyond the solar system, carrying secrets of realms never explored by human instruments. If he bore the chemical imprint of another star system, perhaps he also possessed behavior unfamiliar to earthly science. This raised questions about how planetary systems elsewhere form comets and small bodies based on principles radically different from ours. Do stars with different radiation fields or magnetic environments create travelers that may behave unconventionally for us? If so, every interstellar object entering the solar system was a messenger not only of alien matter, but also of alien dynamics. Over time, the data did not diminish the panic. On the contrary, they confirmed the constancy of the anomaly. The new course of the 3 eye/atlas remained stable, confirming that the deviation was not a temporary effect, but a complete redirection. Observatories in different hemispheres confirmed the measurements, eliminating the possibility of local error or instrument failure. The global scientific community, often prone to skepticism and rivalry, found itself united before an obvious fact. Space had just presented them with a task that no one could ignore. Beyond pure science, the consequences began to spread. Agencies involved in planetary defense faced urgent questions. If an object suddenly changed direction without warning, what would it mean for early warning systems designed to detect and deflect potential threats? The principle of safety was based on the predictability of trajectories. Even when the threat came from an asteroid, humanity could calculate where it would go and when. But if unpredictability has now become a reality, the entire paradigm of protection needed to be reconsidered. It seemed that the foundations of survival had been undermined. Meanwhile, physicists began to seek explanations beyond traditional theories. Some suggested that the object might interact with invisible structures of space, areas of dark matter that eluded detection but had a local effect. If such areas really exist, then the 3 eye/atlases could have become the first noticeable victims of their attraction. This idea was shocking, as it suggested that the invisible structures of the universe, long theorized but poorly researched, could be not a passive backdrop, but an active participant in shaping trajectories. Panic in the scientific community was not caused by the fear of immediate destruction. Rather, it was anxiety from the realization that space might be stranger, more complex, and unpredictable than current models allow. The cultural impact was instantaneous. News agencies broadcast images of comet-like objects rushing through black space, accompanied by headlines about the sudden change in their trajectory. Although journalists avoided technical terminology, the message to the public was quite simple. Something in space changed direction, and scientists did not know why. This uncertainty engulfed societies that often turned to science for answers. The idea that experts acknowledged their uncertainty caused shock and fascination. Online forums buzzed with speculation, from exotic new physics to artificial origins. The phrase, suddenly changed course, gained almost mythical significance, implying a volitional act that should not have occurred. For philosophers and thinkers, this moment held symbolic power. The sky, once considered unchanging, had already been overthrown by centuries of astronomical discoveries. But this was a fresh reminder that even in the age of satellites and space probes, mystery remains supreme. This event raised ancient questions about humanity's place in the universe, the limits of knowledge, and the humility required before cosmic scales. In a state of panic, we remain human, facing a miracle. In the laboratories, the reaction was more technical, but no less tense. Data analysts worked sleepless nights trying to find correlations that could clarify the cause. They studied the fluctuations of solar wind, variations in the interplanetary magnetic field, and even the subtle influences of cosmic ray streams. If the object interacted with any of these phenomena, signatures might have been hidden in the data. But nothing obvious was found. The stubbornness of the anomaly was driving them mad, as the more they tried to understand, the less logical the situation seemed. Theories multiplied, but each faced criticism. Some speculated that the object might have internally collapsed, ejecting mass that would serve as a thrust. However, there was no visible field of debris behind it. Others hypothesized that hidden icy layers beneath its crust could have exploded, creating invisible jets. But the lack of significant brightness in its coma refuted this. The more traditional theories failed to explain, the more radical the ideas became. Some quietly spoke of interactions with exotic particles, or even the possibility that interstellar objects could be subjected to forces beyond the known four interactions of physics.